Welcome to Automatarium, the next-gen platform revolutionizing the way we explore formal languages and automata theory. Step into a modern, intuitive experience designed to empower your learning journey. Let's embark on a voyage into the core features and the magic behind Automatarium. In this tutorial, we'll learn how to create pushdown automata. Let's dive in. Context-free grammars are more powerful than regular languages. The essence of their power comes from a stack mechanism. In pushdown automata, or PDAs, the push operation places a symbol on the top of the stack, while pop removes it. Simply reaching the final state isn't enough for accepting an input string. The stack must also be empty. Let's walk through the creation of a PDA that recognizes palindromes containing the alphabet A, B, C. Navigate to the Automatarium webpage and click Start Building. From the available options, select to create a new pushdown automaton. Using the State tool, add two states to the canvas. We need to designate our initial state and a final state. Access the State menu by right-clicking on Q0 and select Set as Initial. Right-click on Q1 and this time select Toggle as Final. Now select the Transition tool. For our palindrome language, we'll create 3 self-loop transitions at Q0. You can make a self-loop by clicking the state while the transition tool is active. We'll add 3 transitions, leaving the pop field with the default value of lambda. In Automatarium, lambda represents the empty string. For the input A, push A onto the stack. For the input B, push B onto the stack. And for the input C, push C onto the stack. Add a transition from Q0 to Q1, leaving the read, pop, and push fields empty. This indicates the midpoint of the palindrome. Include additional lambda transitions for popping each of the letters, allowing for palindromes with an odd number of characters. In the state Q1, add 3 self-loop transitions to handle some pop operations. For the input A, pop A from the stack. For the input B, pop B from the stack. Finally, for the input C, pop C from the stack. Click the flask icon located on the right-hand toolbar or use Shift 1 to access the testing lab. Type A, B, C, B, A into the trace field and progress through the input sequence using the directional buttons. This visual guide, the trace panel, maps out the automaton's journey for the given input. We can switch on the trace tape feature for a visual representation of the input tape. Observe the stack visualizer at the bottom left of the screen. It enables us to clearly see the state of the stack at any point during the traversal. On entering a non-palindrome, such as A, B, C, D, the Trace tool will highlight the lack of a suitable transition for the D character when in state Q1, resulting in a rejection of the input. For simultaneous testing of multiple strings, we can use the multi-run section. You can continually append inputs, or alternatively, you can batch input multiple strings using copy and paste. Suppose you aim to expand the machine's capabilities to accept our palindrome language, or the string A, B, C. This PDA is non-deterministic, as it contains lambda transitions. Let's expand on the non-determinism of the machine for our new language. Begin by creating 3 more states. From Q0 to Q2, create a lambda transition that pops C. This will ensure the last input character in the string is C. From Q2 to Q3, make a lambda transition to pop B, and from Q3 to Q4, pop A. We should designate Q4 as a final state through the State menu. Let's go back to the testing lab to see whether the machine accepts A, B, C as a valid input string. We have the string in our multi-run already, so let's simply press Run. As you can see, the input is now accepted. Open the stepping lab by clicking the pause symbol or by using the keyboard shortcut Shift 2. Let's visualize how the string A B, C traverses the PDA. The arrow buttons allow you to navigate through transitions, with active states lighting up once they've been reached. Use the forward button to step through each transition. You can start over by pressing the reset button on the left. For a detailed overview of your automaton, use the shortcut Shift 3 or click the Info tab in the right-hand toolbar. Here you can find the alphabet, state transition table, and transition function. To share your machine, navigate to File, then Export. You have the options of exporting as an image, JSON file, or URL. With the close of this tutorial, your journey into the world of Automatarium is just beginning. Embrace the tools, the features, and the intuitive design that awaits you. Remember, every challenge in understanding is an opportunity for growth, and Automatarium is here to guide you through it. For more information, our contact details and a link to our GitHub repository can be found in the video description below.